So now let's talk about inclined planes. This is one of the 6 kinds of simple machines we've talked about in this chapter. It's the one that we did on the first day we talked about them. So let's start here. An inclined plane is a flat sloped surface. We've typically talked about it as being some kind of ramp. And certainly those are inclined planes, but even just a hill is an inclined plane, a flat sloped surface. The input force to move an object is less than the output force or the weight of that object because the force is exerted over a longer distance. So we can figure out the mechanical advantage of any inclined plane this way, the length of the incline divided by the height of the incline. But before we even do that, let's just talk about an example. So my family and I moved recently to a different house, and we had to move Hayduke's doghouse. Hayduke has a monstrous doghouse. So we had to get it up into a moving truck, right? Let's say that the moving truck's floor was a meter above the ground. And let's say I had to use either a 2-meter long ramp or a 6-meter long ramp in order to move it. Which one would you rather push something really heavy up? This short ramp or this longer one? Well, hopefully you said this longer one, and that should be pretty intuitive, right? You can see that the slope isn't as bad, so it would be easier to push something heavy up this. So we've described that in a qualitative way. Let's describe it in a quantitative way using this math problem. The ideal mechanical advantage of an inclined plane is the length of the incline divided by the height of the incline. Let's do that for the short one first. So the length is 2 meters, the height is 1 meter. So the IMA here, 2 divided by 1 is 2. Now, this is a good time for us to talk about units. Mechanical advantage does not have units. It's not really a measurement. It's more like a relationship. So an inclined plane of this size is going to double the force that I am able to put into whatever I'm doing, but it's also going to make me go a longer distance. So it's not a unit thing. It's just a relationship. If you like math and you like to cancel things, then certainly you can do that. And that's another way to look at this. If we take 2 meters divided by 1 meter, we can cancel those m's, right? Leaving us with 2 over 1, which is 2. So this one, the 2-meter ramp, has a mechanical advantage of 2. Now let's talk about the 6-meter ramp. Same thing. We've got the length divided by the height. So 6 divided by 1 equals, we could cancel those two, 6. So the mechanical advantage of this ramp is 6, meaning that I'm going to have to move my doghouse 6 times farther than if I just lifted it up, but I'll be able to move 6 times the weight with the same amount of force if I just push that up the ramp. Now, of course, this is oversimplified. We're not talking about friction here. There are lots of things we're not talking about. We're trying to make this simple so that we can separate the idea of an inclined plane from lots of other ideas that we've talked about already in physics and that we'll be getting to. This is just taking out the simple part of figuring out ideal mechanical advantage for inclined planes and applying it here. Something to remember, just the longer the inclined plane, the less input force is needed to push or pull the object.